Hello everyone, I'm making a video to hopefully help you guys understand this topic a little better. If you feel like you already understand this topic, you can move on to the next video. That's going to be on later topics that will be covered as well. So in this one, we're again talking about changing between the log and exponential form. So the main thing that you need to understand first before we start to do this is that you need to understand this. Okay, so in math we always have inverses, like opposites from one to the other. So for example, we have division and multiplications are opposites. So adding and subtracting is opposites. Even square and square rooting are opposites. And what opposites, or what we call inverses, do when we apply them in an equation is that they cancel each other out, right? So we need that idea for logs and exponentials as well. They are inverses, so they'll cancel each other out when you apply them to one another. Now, we're going to use that idea to help us transition or convert between logarithms and exponential form. So I have 3 examples of logarithms and 3 examples of exponential. So what I want you to do is I just want you to pause the video, try to see if you can, if you understand this already, try to see if you can do this. But if not, just pause it, write them down, and then we're going to go over it together. So hopefully you wrote it down, and we are going to try this method that that might be a little different from the previous Khan Academy videos. We're going to try to use this idea of inverses. Logs and exponentials are inverses. So if I apply the inverse to its equivalent part, it should cancel each other out, right? So I see here I have first log base 7 of 49 equals 2, and I want to convert this to an exponential. So what I'm going to do is I'm going to apply the same base of 7, to both sides. So I'm going to pretty much do 7 to the power of this entire thing equals 7 to the power of 2. So I did 7 to both sides, just like I would do for like adding. If I want to do the inverse, I would like add to both sides to cancel it out, right? So I'm doing the same thing. I'm applying the 7 to the power of to this entire left side, but since I did it to the left side, I have to do it to the right side as well. Okay, so what happens is this base 7 and this log 7 cancels out, and we have 7 to the power of 2 equals 49. Okay, so these are equivalent equations. Okay, all I did was just manipulate it and change it to an exponential form, but these two are exactly the same. Okay, you'll get the same, it's the same meaning. All right, let's try it one more time. So log base 4, 64 equals 3. Okay, so I'm gonna again identify the log base that I have, which is a 4, and I'm gonna apply that as an exponential to both sides. So 4 to the power of log 4, 64 equals 4 to the power of 3. Again, 4 to the power, or 4 base, cancels out with the log base 4, and you're just left with 4 to the power of 3 equals 64. Right? Now these exponents should make sense. 7 squared is 49. 4 to the power of 3 is 64. If you manipulate it somehow and you got something that does not make sense, like 4 to the power of 64 equals 3, right? That doesn't make sense. So you probably did something wrong there. So you should go back and reconvert it. Okay. Last one here, we're throwing in a variable, but same thing. It's a base of x, so I'm gonna apply an exponential of x to both sides. So now the exponential of x and the log base x gets canceled out, and I have x to the power of 3 equals 8. In a later video, we're gonna learn how we can solve that. Some of you guys may already see how you can solve it, but pretty much we're gonna solve for x after this step in a later video. Okay. Let's try that. Excuse me. Let's try that with exponential form now. So we're going from exponential to log. So if I want to cancel out an exponential form, I'm going to apply its inverse, which is logarithm. So I see that I have a base of 7 for my exponential. So I'm going to apply a log base 7 to both sides. Okay. Now, if you're not familiar, log that mini 7 does not multiply to that 343. It's just a mini, it's like a symbol that tells you we're doing a base of 7. So we're not multiplying to 343 here. So what will happen, log base 7 and the power of 7, and the exponential of 7 cancel out because they're inverses. And what we're left with is log base 7 343 equals 3. We're going to see later why this is true, but for now, we're just going through the process of converting, but we will later figure out why this is true. Okay, next example, base 11. So 11 to the power of 2 equals 121. That should make sense. Now when I convert it, I'm going to do a log base 11 to both sides. Log base 7, or log base 11, and the exponential base 11 will cancel out, and we are left with log base 11, 121 equals 2. Then finally, the one just thrown in a variable, but that's okay, same thing. I have a base of 2, so I'm going to do log base 2 to both sides, so I can cancel out that base of 2. And I get log base 2 of 64 equals y. Again, we're going to learn later how we can actually evaluate this so it makes more sense. But right now, we're just learning to convert between exponential and log forms. So hopefully that helped. Move on to the next video or replay this video if you need an extra go at it.